Tachyons, though purely hypothetical, represent one of the most exciting and curious concepts in theoretical physics. These particles are believed to always travel faster than the speed of light, an idea that challenges everything we know about how the universe works. Could tachyons exist? And if so, what would that mean for our understanding of time, space, and causality? Breaking the speed of light. What are tachyons? In Einstein's theory of relativity, the speed of light is considered the cosmic speed limit. Nothing can go faster without requiring an infinite amount of energy. But what if there were particles that never traveled below the speed of light? This is where tachyons come into play. According to their theoretical framework, tachyons would always move faster than light, which creates some truly mind-bending consequences. Tachyons, unlike ordinary particles, would not experience time the way we do. For us, time flows in one direction from past to future, but tachyons moving faster than light could seemingly move backward in time. This isn't just science fiction, it's a direct implication of special relativity. If tachyons exist, they could, in theory, send signals or information into the past. Imagine the implications of sending a message to someone before it was even written. Violating causality, why it matters. The idea of tachyons transmitting information backward in time presents a direct challenge to causality, one of the fundamental principles of physics. Causality means that an event, the cause, always leads to another event, the effect. If tachyons could travel into the past, they could reverse this order, creating paradoxes. For instance, you could receive a message telling you to avoid sending that same message in the future, leading to a logical inconsistency. This brings us to thought experiments like the grandfather paradox, where a person travels back in time and prevents their grandfather from meeting their grandmother, which in turn would prevent the time traveler from ever being born. If tachyons can transmit information backward in time, such paradoxes could become a reality, creating situations where effects occur before their causes. So while tachyons are tantalizing to physicists for their potential to break the light-speed barrier, they would force us to fundamentally rethink our understanding of time and reality. Why haven't we found tachyons? Despite the fascinating possibilities, no experimental evidence for tachyons has ever been found. Many attempts have been made to detect these faster-than-light particles, but so far none have been successful. One reason could be that tachyons, if they exist, might interact with normal matter and energy in ways that are incredibly difficult to detect. They may only interact through gravity or in some other exotic manner that current technologies can't measure. Moreover, the concept of tachyons raises significant theoretical challenges. For example, if tachyons exist, they could possess imaginary mass, a bizarre concept where the mass isn't a real number, but a mathematical construct. This makes working with tachyons within the framework of current physics highly problematic. The speculative frontier. Despite the lack of evidence, tachyons remain a popular subject in theoretical physics because they push the boundaries of what we know. Their potential to send signals backward in time or travel faster than light is an idea that excites both physicists and science fiction writers alike. Could they be out there eluding our detection, or are they simply a quirk of mathematics existing only in theory? If tachyons were discovered, it would revolutionize our understanding of the universe and force us to confront questions about time travel, causality, and the very nature of reality itself. The search for tachyons continues, and with it the possibility that faster-than-light particles could one day open up new realms of physics we can only begin to imagine.